doing today? I don't have anything written on my paper. How in the world would you know what we're doing today? Oh, the lesson plans. They're written up on the board. Good job. And you already wrote them in your paper, right? In your lesson plan section? So let's work on adding and subtracting and multiplying polynomials. Everyone knows that's super hard. Right? Adding and subtracting, that's super hard? No, not at all. Okay? So here we go. 3x to the fourth. You can't see that very well. Where'd it go? What is happening? Oh, okay. Whoa, what in the world did it do? I'm super confused. Let's try this again. Is it freaking out? Look how much it zoomed in. I don't want that. Can you help me out, please? That's a little better. Okay, is that fine? What in the world did it do? All right, 3x to the fourth plus 2x to the third minus 4x squared minus 5x minus 10. Plus 3x to the third plus 2x plus 5. What is it asking for us to do? Add them. We are combining like terms. That's exactly what we're doing. Okay? If I'm combining like terms, what do I write down first? Okay, which one is the biggest one? So you're saying the biggest because of the 3? Oh, so the highest exponents we're talking about, right? Okay, so 3x to the fourth comes first. What exponent would come next? To the third. Well, I've got 2x to the third and I've got 3x to the third. Are you sure it's not 5x to the sixth? Good, and I need you to be sure of that. Because when we add or subtract, we do not mess with our exponents. Okay? So I've got exponent to the fourth, then exponent to the third. So now we need squared. Now, we had a little argument earlier because some people were saying squared and some people were saying to the second. And I was like, you guys are saying the same thing. Slightly different vocabulary, but you're talking about the same thing. Stop arguing. That's what I said. It's okay, though. They're fine. What goes next? So negative 4x squared. There's nothing to add to it, though. There's not an x squared over here. Is that okay? Yeah. Then I have negative 5x and 2x. So negative 3x. And then we have minus 10 plus 5. Minus 5. Why is it what? Somebody said, why is it? And then I couldn't hear the rest of it. Oh, you were just amazed by it? Awesome. Guess what this is? The answer. We're done. That's adding. Do I need to do any more examples of adding? You can handle that? Okay. What is it asking us to do? Subtract. So we have two choices here. Okay? We can actually subtract like it says, or we can add the opposite. A lot of times people who struggle with subtracting prefer to add the opposite. Okay? Because what's really right here? Is there really a 1 right there? So couldn't I distribute this -1 to each term over here? And wouldn't that just be an addition problem then? So I could be subtracting 2x to the third, and I could be adding 8x squared, and I could be subtracting 2x, and I could be subtracting 3 from this original problem that I had. Does that make sense? So now what? Come on, your like terms. 4x to the third minus 2x to the third. 2x to the third. Negative 6x squared, positive 8x squared. (7x minus 2x). And negative 12 minus 3. Why do people prefer to do it that way? Do you know? Can you just look at the red and just go by the red? Yeah, for sure. You have to remember to say 4x to the third minus 2x to the third. People don't usually have problems with that. People have problems with the next part. Negative 6x squared minus a negative 8x squared. You know what they usually put? Negative 14x squared. Because it's a negative 6x squared and a negative 8x squared. They forgot the minus. I don't care which way you do it. I want you to choose a way and stick with it and get it right every time. Is that all right? Any questions about subtraction? Okay, let's talk a little bit about multiplication. What are we going to do when we're multiplying here? Okay, so can we have a slight conversation real quick? Okay, somebody just said FOIL, and somebody over here said FOIL earlier, and somebody over there said FOIL earlier. Okay? Respectfully, I mean this respectfully. Okay? That's what we say when we first learn this, because we have to do baby steps when we first learn it. We're not babies anymore. We need to use the correct vocabulary. Okay? What are we doing here? We are distributing. We're not foiling, okay? And I'll show you why in just a second. I promise I'll show you why in just a second. We need to distribute because that is the correct math term for what we're doing right here. Is that fair? I'm not mad at you. I just want us to make sure we're using the correct vocabulary. Because if I was mad, trust me, you would know. So what do I get when I distribute that? 12x to the third. Why did you get x to the third? Because when we multiply like bases, what do we do with the exponents? Add them. Okay? What do we get when we distribute that? Negative 3x squared. And what do we get when we distribute this? Negative 30x. And guess what that is? The answer. I forgot to circle the answer up here, sorry. That's the answer. Can I show you an example of why we don't say FOIL in Algebra 2? Yes? Yes, you're going to write it down. If I write it down, you write it down. Unless I tell you not to write it down. Most of the time I will not. If we're trying to do FOIL, we are in trouble. Because if we're doing first, outside, inside, last, we've just skipped this whole term right here. That's not okay. If we distribute, however, we're going to take this first term and multiply it by every term in the second parentheses. We're distributing that term, multiplying that term times each one of these terms. And then if we distribute the 5, we multiply it times each term in the second parentheses. Does that make sense? That's why we distribute and not quote-unquote FOIL. I know that you know what you're talking about when you say FOIL, but remember, one of my jobs is to make sure we're using the correct vocabulary. Is that fair? Okay, so what do I get when I say x times 2x squared? 2x to the third. What do I get when I say x times negative 4x? Somebody else. Negative 4x squared. And what do I get when I say x times 5? So plus 5x, right? Now, if you're a visual learner, like I am, can I show you how I do this problem? There's 0 problems with keep on going this way. Okay? 0 problems at all. But can I show you how I do it? There's not a right or wrong way, just to be fair. Okay? 5 times 2x squared. 10x squared, I'm going to write it right here. Why am I going to write it right here? It's with the like terms now, right? Could I write it over here and keep going this way? Absolutely. Okay? What about 5 times negative 4x? Negative 20x. And what about 5 times 5? Only difference now is I'm just adding vertically instead of horizontally like I was doing up there on those other problems. 2x to the third. And then plus 6x squared. Somebody else? Minus 15x. And somebody else. Hopefully you can get that last one. And guess what this is? Answer. How comfortable are you with adding, subtracting, and multiplying polynomials? Okay, so to be fair, you're comfortable with adding, subtracting, and multiplying. Are you comfortable with polynomials? What does it mean? What does polynomial mean? What does poly mean? Many. And what does nomial mean? Number or terms. Okay? Because this is a constant, right? This is a term because it's got a number and a variable together. That's just not a number. That's a number. This is a term, right? So it's many numbers or terms. You okay with that? So now, are you comfortable with adding and subtracting and multiplying polynomials?